Hello, you're welcome back. All right, so we are going to continue from where we stopped now. We are going to look at more example in this video. All right, so let me start with the very first question here. All right, so determine the temperature of water at the state of P equal to 0.5 megapascal and H equal to 2890 kilojoule per kilogram. Okay, so the H is the enthalpy. All right, so we are to determine the temperature. Now, as you can see, the water that is actually given to us, it wasn't specified that the water is saturated liquid water, all right, for us to read it from our saturated liquid water table. So we don't know the state of the water. So how do we know the state of the water? What we are going to do is we are going to go to our saturated liquid table of water to read the enthalpy that corresponds to this pressure. So if the enthalpy that corresponds to this pressure, we are going to read the enthalpy for both the saturated liquid and that of the vapor. Okay, so you know the condition. All right, so let's look at that. So if you go to the table, you can actually go to the table to confirm. All right, at the pressure of 0.5, at the pressure of 0.5 megapascal, okay, now if you read the entropy of the vapor, that is the enthalpy, please pardon me, not the entropy, the enthalpy of the vapor Hg, the value you will see is 27. Okay, let me look at 2748. Okay, so that's the value you will have, 2748.1 approximately kilojoule per kilogram. Now let's actually compare it to this. So as you can see, the entropy that is actually given is greater than what we have here. So this entropy, the enthalpy, please pardon me, the enthalpy that is given is greater than the enthalpy of the vapor. So H is greater than Hg. And you know, for this actually shows that this particular, the water is superheated. So this is superheated, okay, superheated vapor. So since it's superheated vapor, we can now read the temperature, okay, the temperature at the superheated vapor table of water. All right, so now when you get to the superheated vapor table to read the temperature at this particular, at this enthalpy, the enthalpy of 28990, all right, you will discover that you will not have this particular value, but you have a value that is less and greater than this. So now if you go to the table, you are not going to see, okay, a particular value for enthalpy. All right, this is let's say this is enthalpy column, which of course is in kilojoule per kilogram. So you're not going to see 2890, but rather you're going to see two values in which 2890 is in between it. All right, so the two values are, you rather see 2855, then you will see the value after 2855 is 2961. Okay, the value after 2855 is 2961. Okay, so which simply means that the enthalpy, the one that is actually being given, okay, the one that we are to find the temperature that corresponds to it, is in between this. So it's in between it. So that is in between it, we are having 2890. So the question, how do we find that? how to find the temperature of the 2890. Now, the temperature of the 2855 enthalpy is 200. So we don't know the temperature of the 2890. Let me just call it T. So this is T in degrees Celsius column. All right, and the temperature for 2961 is 250. So how do we now get this? Okay, this is where we applied the method of linear interpolation. Linear interpolation. So what we simply going to do is to find the equation of this particular table of value. Okay, so this is actually a linear, this will give us a straight line graph. Okay, so we'll have to find the equation of this straight line graph. So what is the formula? Remember, the formula of a straight line graph is given as okay, a straight line graph that is actually passing through a point. So of course, if you can remember, y is equal to mx minus x1 then plus y1. So in this case, the y is the, of course, is the dependent variable, which is h in this case, while the x is the independent variable, which of course is t. All right. So of course you know how to calculate the slope. So in this case here, the slope is going to be equal to change in h, delta h all over delta t. So delta h is 2961, of course, divided by change in the temperature, which of course is 250 minus 200. Okay, so 2961 please, 2961 minus 2855. So if you do this correctly, you will end up having 2.10. Okay, let me forget, let me not bother about the unit. All right, so applying that, okay, let me clean this. So applying that the general equation, you know, of course, the equation is going to be equal to h is equal to m, which is 2.10, then x, which of course is t, minus t1 is 200, then of course plus h1, which we know is 2855. So we are going to get, this is, once we've gotten this equation, now we can use this equation to find the temperature that actually corresponds to this enthalpy 2890. That's what we are doing. All right, so let's see what we have. So if you open this, you end up having open this bracket, you end up having 210 t then minus, okay, multiply this 2.10 multiplied by 200, then add it to, of course, add it to this, you will have, that is h is equal to 2.10 t then minus 2434.2. okay, all right, so this is the expression. So now from this equation, now we can find the temperature that corresponds to h, okay, when h is equal to 2890. To find the temperature, so what we're simply going to do is to make the temperature the subject. So the temperature is going to be equal to, okay, so h is equal to, making temperature the subject, so this is temperature is h, move this to the right side, plus 2434.2, of course, then divided by 2.10. So the h now is, of course, is 2890 plus 2434.2 divided by 2.10. okay, so calculate that using calculator. Let's see what we have. Okay, let me get a calculator. So So what we have is of course 2890 plus 2434, okay, 0.2, of course, divided by 2.10, so 25, okay, 35, if I'm not mistaken. Let's okay, 2535. So that temperature is 2535 degrees Celsius. So I hope that is well understood. Okay. All right. So let's proceed with more questions. So that's here. There's another example. Okay. So this one goes this way. Determine the mass of the air in a room whose dimensions are 4 by 4 meter by 6 meter. Okay, this dimension is not complete. Okay, let me write it out. Okay, the question wasn't complete. Okay, let me check where I wrote the question. Okay, so this the dimension is okay. The actual dimension is 4 by 5 by 6. So 4 meter by 5 meter, of course by 6 meter, and the pressure is 100 kilopascal at 25 degrees Celsius. So we have to determine the mass of the air. So mass of the air in a room whose dimension is this. Okay. All right. This was this particular question is okay. This one is after we have treated ideal gas equation. There's another question I want to solve before I solve this one. This one right here. Let me go down. There's supposed to be another question. Another question here. Okay. There's another example that I'm supposed to solve before I now go to the ideal gas equation. I hope I have that question. Okay, so this is okay. All right, so this was supposed to be the question, or have I solved it already? Okay, I've solved it already. Okay, so I'm going to stop here for now. We're going to look at more in the next video. So see you in the next video. Thank you very much.